What's going on, guys? Welcome back. Today we're doing the recent room on Splunk, new hire old artifacts. Investigate the intrusion attack using Splunk. And in this scenario, we're going to analyze the logs taken from a machine assumingly was operated in the finance department of the said widget LLC company. So in here, the logs have been pulled and we're going to investigate the logs. We need to find out the evidence or patterns of malicious files or malicious executables used to turn off the endpoint security product. Supposedly it's Windows Defender. So this is a guided investigation. We're going to use the questions as a guide to investigate what happened. So the first question, a web browser password viewer executed on the infected machine. What's the name of the binary? Enter the full path. So first we put in the index and we explore the different source types we have. That's the first thing. We have sysmon, as you can see, along with Windows event logs. We're going to investigate first the sysmon operational logs. We have 13,922 events. So we want to find out what's the web browser password viewer that got executed. So first we're going to use the event codes to narrow down the search for the processes that have been executed. And from that point, we're going to look for the password viewer. So for event code, the process execution event code is most probably, let me look, it is 1. For sysmon events, so we're going to click on 1 here, and we got 179 events. Okay, as you can see on the left, we have the image indicating the name of the file or the binary that got executed. We also got the description and the company name, the command line. Let's put all of these in a table to be able to find that password viewer. So table, image, description, company, and the command line used to execute the image. Alright, so this is the image. We're looking for a pattern of password viewer. So if you look at the column description and company, it's going to give you a hint about the origin of this executable. So all these are Microsoft Corporation. Let me do one thing here. Let's use dedup to cancel all of the duplicate images, because maybe the same executable ran more than one time. We want to see only one instance of every executable, so we're going to use dedup on the image field, and we reduce them to 50 entries. So let's take a look here. So immediately we see on the description the second row, web browser password viewer description, and this is the company, and this is the command line used to execute the tool, and this is the tool itself, and that's the full path. And that's the answer for the first question. Following by that, the name of the company can be seen here, the company that developed the product. But obviously the person who downloaded the product has changed the name of the tool. Another suspicious binary running from the same folder. So before we continue on the rest of the question, let's note down the folder. It's users app data local temp. From the same folder, we have got another executable run. What's the name of the binary? What is listed as its original file name? So we are operating on the same folder here. So let's go back now, and we stay in the event code 1 since we're looking at the binaries that were executed. Current directory, let's sort for the temp directory. And we got 5 events. Let's use a table, image, original file name. Original file name is a field that I got from here, okay? If you have questions or where it came from. So the question is, not this one. Yeah, 2 binaries executed from the same workstation. What's the same directory? What's the name of the binaries and the original name? So let's see here. Okay, so as you can see here, we have these. Okay, now this one is scheduled task, this one is build, update Windows, and we have these Ionic Large, and that's the original name. As you can see, Elite Explorer. This is your answer. The binary from the previous question, this one, made 2 outbound connections to a malicious IP address. What was the IP address? Enter the answer in define format. So let's take first the executable and sort the events that contain this executable. We have 189. We want to find out the outbound connections. So we're going to look at event code that indicates network connection, which is 3. So 3, event code 3. And we reduce them to 87 events. Okay. Now if we scroll all the way down, we take a look at the destination IP address. As you can see, we have 8, right? Now the question is stating that the binary made 2 connections. We have 1 IP address to which 2 connection attempts have been made. If we click on that, we can see that the executable that made the connection is Ionic Large. And that's the IP address. Of course, you use CyberChef to use in this format, defunct format. The same binary, Ionic Large, made some change to a registry key. What was the key path? Again, we're looking here to, we're going to go back. Okay. And we're going to use the event codes again. So for registry event, we have 12, 13, 14 for registry updates, modifications, and creation. If we take a look here, so for 12, we got 2 events, 13, we got 9 events. We're only required to put the path. So let's take a look at the 12. As you can see, this is the path modified. And this is the key. So it's trying to modify on the Windows Defender. Most probably it's disabling Windows Defender. And we got this one. Okay. Now if we go back and put 13, we're going to see a pattern of modifications made on this key or on this path, Windows Defender. This one and this one. And all the way down the same path. That's the path that to which the modifications have been made by this binary, trying to disable Windows Defender. Some processes were killed and the associated binaries were deleted. What were the names of the 2 binaries? Again, process termination event code is 5. So let's see here. Event, let's cancel this one and look at the terminated processes. 92, we're going to use the table again. So let's see, computer name, image. Do we have other fields to help? Message, not helpful. Okay, let's put these in a table. Table, image. So, 2 processes were killed and the associated binaries were deleted. What were the names of the 2 binaries? Let's use DDub first, because the process itself may have been terminated more than one time. So we're going to use only, so 40 events. So all of these processes or executables have been terminated. We're going to find out which ones are the correct ones here. There is another hint. The binaries were deleted. So if we take a look here, guys, let's see at the path. So up data, and we have this one. Trust certificate is not the one we're looking for, and process monitor is not the one. We have easy calculator. Okay, these are for Adobe. Let's filter for the directory. See if we have directory field here. Directory. Okay, we don't have this. We want to show only the terminated processes at the temp directory. So let's go back, DDub, image, and table, image. Case sensitive. So if we have this one, in up data. We have also this one. If we scroll down again, so at the temp directory, we have these two looking suspicious. This one, this is local, no. This one, and this is license agreement, no. So we're going to take a look again. Temp. كالنخرة. As you can see here, it's very hard to find out. So we're gonna need not to rely on the event codes this time. Let's go back and see another way of locating these terminated processes. Okay, so if you take a look at 50 more fields here, we have command line, we have company, current directory is helpful, description, destination IP, destination port, event code. We had these, right? I don't know why they got away from the list. Image, original file name, parent command line, query name might be helpful, and source IP, source port. So if we cannot locate the terminated processes using the event code, we're gonna need to locate them some other way. So normally when you terminate a process, you can terminate the process either from the task manager or from the command line. So let's look at the command lines here. So if we sort these, say dedup image, okay, and then table, command line, parent, command line, description, image. Okay, let's look at the commands. So we have this one. We're looking for a command that's used to delete or terminate a process. Delete or terminate, either one of them would work. So these are empty, timeout, task kill. Look at this one. Task kill is used to kill a process, right? As you can see at the end, we deleted the process. So the executable name is this one that was terminated. This is the first one. This is notepad. Okay. Somehow similarly another command should be here that indicates a process termination. Seems like we missed it, right? Okay, so let's search for task kill in that case. Since we located one, we should be able to locate the other one. Task kill. Thirteen events. All right. Table. Command line. So that's the first one, the first instance. The executable that were killed is this one, and later deleted, as you can see, erase. In another way, or the same way, that executable was terminated and deleted later. This is the answer. The attacker runs several commands within a PowerShell session to change the behavior of Windows Defender. What was the last command executed in the series of similar commands? Here we're looking to filter for PowerShell events. PowerShell. And we're gonna go for the command line. So table, command line. Let's take a look at the commands that were used in PowerShell. So the question here is saying, wait, what was the last command? So we're going to use the table time here. So table underscore time to sort these commands. The last one. So we're going to sort them like that. As you can see, PowerShell executed, empty, Wait, let's do this. DDub command line to cancel all of the empty entries. All right. So before the last one, we got this command. That's the last command executed in PowerShell. And that's the answer for your question. Based on the previous answer, what were the 4 IDs set by the attacker? Enter the answer in order for execution. The attacker used PowerShell to modify entries on the Windows Defender. That's the first ID, right? Or maybe the last one. That's the one before the last one. Okay, and you can find them here by looking at every single command. And 3, the 4th ID here, and the last one is not here. How many IDs? 4, right? Yeah, 4 IDs, exactly. Another malicious binary was executed on the infected workstation from another up data location. What was the full path to the binary? Let's filter for the directories, or for directories where the application is highlighted. So let's go back and use the directory field here on the left, current directory, and up data. Let's see where is up data. So I have more than one up data here. Let's take a look at the question again. From another up data location. So the last one was this one. We can also take a look at this one. Let's see. Okay. So let's sort or put them in a table. Image, command line. So maybe we have to, let's go back. Let's cancel these. Put only up data. 0 events. How about this? Let's escape these, adding more, like 0 events, still 0 events. Let's go back. Current directory have 22. Let me list these current directories. Table current directory. You may have to read up so often while dealing with Splunk. Okay, these are the directories. So we have up data local temp. All of these were temp. The other page. Another up data location. All right, let's copy that. And let's try one more time. Don't forget to escape the backslash by adding 2 backslashes. So we have 5,000 events. Okay. Let's now use DDub image table image original file name command line. Okay, so it's a suspicious binary, so definitely it's not Adobe Films. This one we located, this one, process monitor, easy calculator. Let's use description so it can help us having some insight on the nature of the binary, description and the company. So we have empty description for easy calculator, which is suspicious, by the way. If we scroll down, this is from Adobe. Update Windows build. These are normal executables. Install. These are also suspicious, right? But these aren't the answer for the question. The answer for the question is this one. Easy calculator. What were the DLLs that were loaded from the binary? From the previous question, enter the answers in alphabetical order. So what we can do, we can take the name of the binary, okay, and go back see how many events are related to that binary, and then we can retrieve the loaded DLLs. But how we can retrieve these loaded DLLs? We have to find the relevant field. If we look at event type, doesn't help. Message, nope. Do we have more fields to extract? Seems like we have. Event type. Let's take a look at the event type. Create pipe, create key. Keywords, message, let's take a look at the event code. So I'm not sure what event code is related to DLL loaded, but that's not how I answered the question when I did the first time. So I'm trying to remember. If we take a look at, there is a missing field here. Let's take a look one more time. Description, where is the description? Okay, the description here would say it all. As you can see, we have indications of DLLs loaded. As you can see, open source media library, dynamic link library. We have to find out this. So say table, description, $1,000 DDoP description. Okay, great. So we have these, right? We also have to put the path, so maybe we have to resort back to the command, to the original view. I have to find what DLL that has been loaded, so we have to use the image maybe, or original file name. As you can see, we have DLLs here. So let's go back and say here DDoP description, or let's display them as they are. Table original file name and description of the operation. Yeah, DDoP description. We have many empty spaces. Okay, so we have this one, NWJS open source media library. That's weird. And we have this one. This one is this easy calculator. Take a look at this DLL. These are official DLLs all the way here. The malicious ones seem to be this one and this one. But the question is asking for 3, so we might have skipped one DLL based on the DDoP here. So we're going to cancel DDoP here and try to deal with these spaces. That's too long. There must be another way. Let me try one more time. DDoP or let's say DDoP original file name. This one worked. As you can see, we have 3 here, and these are the 3 DLLs that are required to answer the question. So that was it today, guys. I hope you liked that, and I will see you in the next video.